Hey everyone, welcome to AC Academy, and today we are going to be reviewing Algebra 1, Section 1.2.2, and this section details solution sets for linear equations. Okay, we're going to do this problem kind of in two approaches, but let's get into it. The problem asks, which ordered pair is in the solution set of y is greater than or equal to 1/3 x plus 4. So I'm going to rewrite the equation because whenever I was typing this out, it's some of it might not translate the best whenever you're like typing it out. But y is greater than or equal to 1/3 x plus 4, right? So here's our equation we're taking a look at. And we want to see if one of these points, one of these ordered pairs fits into this equation, or rather makes this equation true. Okay, so first I'm going to do a table approach, and then I'm going to do a graphical approach, right? One thing you could also do, if you're in a rush for time during a test or something like that, you can honestly go through each of these equations and plug them in. We know our first column right here is going to be x, and then our second one's going to be y. So you would literally take the x value here, so you would take -6, plug it in, and then you would make y 1 in this case. So let me actually do this for an example. Putting in a, right? This would be y, which is 1, is greater than or equal to 1/3. You have -6 here, plus 4. Okay? And we're going to multiply this out. 1 is greater than or equal to -6/3 plus 4, which, again, simplifying further, 1 is greater than or equal to -6/3 is the same as -2, right? Plus 4. 1 is greater than or equal to 2. So is this statement true, right? After plugging in these equations, is this statement true? Is 1 greater than or equal to 2? No, right? So it's false, so we know it's not A. And you would literally do that for each of these questions, each of these ordered pairs. Now, not looking at this approach, what we would do here is we could do a table approach, right? And we could do a table approach using this equation, which is somewhat similar to what I just did here, but it looks a little bit different. So we have our equation. I'm going to rewrite it. And here we go. Y is greater than or equal to 1/3 x plus 4. I'm going to zoom out a little bit. Hopefully you can still see that. Okay. And we're going to make an x column and then a y column, right? We have our x values range from -1 to 6. But what we can do is just plug in some of these values and then evaluate them up here. For a quick example, if we plugged in x is equal to 0, and also a side note, sorry, this table will help the graphical solution as well, since we're actually using this equation and finding out where it lies on this plot. So first, x equals 0, y would equal 4, right? We plug in 0 to x. 1/3 times 0 is 0, plus 4 equals 4. If x equals 1, 1/3 plus 4, right? And 4 is the same thing as 12/3 plus 1/3. That's going to give us 13/3, which is the same thing. Let me draw some of these arrows. Sorry. Which is the same as 4 and 1/3. So 4.33 2. I'm going to skip some of this stuff, but it's going to be 4.66, and 3 is 4.99. These are all repeating, and so on and so forth, right? So if I'm going to combine these two approaches, just to save a little bit of time. Oh, I cannot draw on that. Can I? Oh, there we go. Okay, so we have plus 4, 4.336, and 3 is about 5. 6 is going to be about 6. This one's going to be about 7. So we know our slope's going to look something along there. And this happens after you plot out everything, right? And then doing the same thing backwards. And you can also use your clues from previous lessons. You know that slope, so in your standard mx plus b format, slopes is going to be rise over run. What that means again, the number up top is how many you rise up or rise down, or like I guess lower, and then your run's going to be on the bottom, right? So what I was doing here, you have 0, 4, and your slope's 1 over 3, so you rise 1, go over 3. You rise 1, go over 3. You rise 1, go over 3. It's the same thing back here. You lower 1, you go over 3. But you're going over in like the negative direction. Same thing, you drop 1, down 3, down 3. Then you plot this out. And it's the same thing as your table here, right? You're looking here, you're also looking here, and you're comparing some of these values. So this one's asking which ordered pair is in the solution set of this equation. Now we can plot some of these ordered pairs. We know A's not it, but we plotted -6, 1. We would see that that's true, right? Because it's underneath and we're looking for a solution that is greater than or equal to, which greater than or equal to, I'm going to use a bunch of different colors here, is going to be in this region. Why? Because we are looking at y. We are saying the y values are greater than or equal to this number, this equation, sorry. Okay, so let's go back and let's look at -1, 6, -1, 6. Okay, that's a possibility, right? It's in that zone. That's B. That's a maybe. Let's look at C. 6, -1 is a no. It's down here in this region. D, 1, -6, no. Right? So we know A is not it, D is not it, C is not it. So our final answer we get is B. All right, and I know I combined a few approaches there, but you generally use the one that's best for you. The graphical one is straightforward, especially if you have a slope such as like 1 over 3. If the slope was something crazy like 57 over 16 or something like that, where you don't really want to count and plot, I would probably recommend this first approach that we use. So that's plugging in the values that they give you, the ordered pair values, putting it in the equation, and seeing if it works. The graphical solution is pretty good for equations that are smaller, and if you have a straightforward slope and a pretty small y-intercept. Yeah, and our y-intercept here was 4. Our slope was 1 over 3, so it kind of fit all three of these approaches, and I want to kind of combine and show you what you can do with a problem that's similar to this. But anyway, thanks for watching. Again, if there's something that you don't understand in the video, or if I don't know, if you have any input into the video, go ahead and leave a comment in the comment section, and I will get to it as soon as I can. Other than that, if you have any tips for improving the videos, or if you have any topics that you'd like to see covered, go ahead and put them in a comment section. I'm trying to go through math and the way it's generally taught. So that's you have your algebras, then your pre-calculus, then you go into calculus and whatnot. But yes, again, thanks for watching, and I will catch y'all in the next video.